Hey gang, this is Mr. Schmidt for AP Physics, September 18th, little video recap of what we're doing today. A few side notes here. In addition to what the roller lab will be discussing, I want to point out a few of the features on the modules, which if you're watching this video, you've probably already come across a few of them. All right, number one, I have loaded the answer key into the last two assignments. Okay, if you remember, I grade your homework on completion and effort, which means I won't be giving much feedback in terms of the answers, but you will be able to check all your answers right here. And that also means that as you spot your own mistakes, then you can note those in your notebook. I highly suggest you have a paper-based notebook that you're writing all the mistakes down so that you don't repeat those. So you have one place where you have all your key equations and all your most common mistakes. So these first couple of quizzes, when they're open note quizzes, you'll have a place to go to right away and to quickly answer the questions. Okay, we'll notice a couple of these, like there's a little trick question here that didn't follow the same patterns as the other ones. There's also one or two typos in terms of units that I cleaned up on the answer key, or like, for example, all these answers I just put on the table because I had Google Sheets do all my calculations for me. So that was the answer key. The other one, you're watching a video right now. So when it's posted to YouTube, there should be that traditional little CC button on it, and it should automatically be creating closed captioning, not necessarily perfectly, but if you're more of a visual learner versus an audio learner, it's a nice feature to add there. Okay, so that is where you're seeing all the different videos and answer keys. And then we can go on to today's assignment. Okay. So I saw this morning, like 10 minutes before I went online, and it is the greatest truth I've ever seen. All the elementary school teachers I know are talking about how everyone's talking and they're all involved and they're talking on top of each other, and there's so many random facts and there's so many like personal things coming out from little kids, and the teacher is just trying to get everyone to settle down and to get through the lesson. However, you all sometimes don't even turn on your screen during time, your camera, don't turn on your mic, never ask any questions. This is especially true during storm time. It was incredibly hard to know if I was going at the right pace and the right detail when there was absolutely no visual feedback or audio feedback or a chat group or anything like that. It did make it hard for me to get my job done or to know if I was doing my job. Okay. Also worth noting here is I had one student emailing me during the lesson. Please direct all your questions to the chat or to the ringing in with your mic for the questions. I simply do not check email until after a lesson is done. And you'll notice on my video, while I'm shooting a video, I also have my email turned off. It's not even available to me during that time. Okay, so today we're starting off our roller lab as we're going to roll something down a ramp and calculate its average velocity and its instantaneous velocity at the bottom of the ramp. Okay, so you're going to have your board, something that rolls, something that measures, and some way to record it. That can be your camera on your phone, that can be video physics, that can be Firefox. There can be a lot of different apps that can make this job easier for you. It's up to you to determine which app is going to work best for you in this process. All right. So part one, you're going to calculate the average velocity of the ball going down the ramp. That should be pretty straightforward and easy, especially considering the last homework we just did. Part two is a little bit bigger of a trick. You have to find the instantaneous velocity at the bottom of the ramp. There's about 3 different ways to do this, and I want to see how you decide to solve this problem. Okay. Also worth noting is there's easy to get scalar and vectors backwards, which is something I, in fact, get backwards occasionally. So scalars are just talking about magnitude, so they're just a number measuring something. Vectors are both the number, the magnitude, and a direction, okay? So if we want to keep track of those two things, this is a NASA site. It gives us a nice example of all the things that are vectors, including displacement, which I'm not sure how clear I was on the other day, which is why I'm going over this again. Displacement is a vector, as is velocity and force. And this will become very important when we start doing things like calculating work and energy, and we want to say force in the same direction as displacement. Well, now we need the vectors to know that they're going in the same direction, okay? As opposed to like, how tall is the desk? It doesn't matter if you measure from the top of the desk to the floor or the floor to the top of the desk. You're still measuring height, or you're measuring length or area or volume. So those can be independent, and those are scalar qualities. All right, so if we come back to our lab here, we're going to see some of the basics. Part 1, you do average. Part 2, you do instantaneous. Okay, and let's take a little walk here to our physics annex, also known as the kitchen. All right, so here we are with my ramp. So this is just a board, okay? I just found a board in the garage. You can use your driveway, you can use just a book, you can use anything that is straight and at an incline, okay? You might also want to try different angles to get a speed that works for you, okay? Remember when Galileo did his, he had a set speed, he had a bell at each of these points, or he moved the bells for certain points, okay? So I measured all mine so they are 20 centimeters apart, okay? And again, just like with your ball drop, you can decide which part of the ball starts at which part of the tape or the paper, okay? Just as long as you're consistent, okay? So you're gonna set this up, you're gonna roll it down, and you're gonna go, okay? Balls have what's called rolling inertia, so it will affect some of your numbers. So if we're going to do it in future labs, maybe something like a frictionless cart or a little toy car would work even better. Okay, again, where do you want to start it? Do I want to start with the back of the paper? That'd be a nice place to start it. So I roll, keep going until the back of the paper. The car is at the bottom of the board, and then I could find my information. Or maybe you want to keep the cart going and measure some information out over here, okay? So other things that are important to note is anything that you learned and suggested on your ball drop lab, you should also implement here. Don't repeat the mistakes in the ball drop lab and then put the same suggestions into your conclusion. Now, whatever came out of those first two conclusions needs to be applied to this situation so that you don't repeat mistakes. All right, with that, have a good day.